Let's now consider tangent planes to surfaces. So what I have here is I have a surface which is an upside down paraboloid. It's this z minus 4x squared minus 1/4 y squared. And what I did was I put the contour lines on there for x equals c and y equals c. C is this parameter here. All right, and and then I put a point on one of them, which is this red one right here. So as c moves, the point moves with the contour lines going in the y direction. All right, and then I made another point on here. I just picked a random point, 1, 2, 2. It's actually a point that plugs in well into this. Comes out nicely, 1, 2, and then z is 2. So that point is right there. Then I figured out the tangent plane from there. So the way I did that was I have the surface here. I took the first derivative with respect to x, the derivative with respect to y, and then here's my point. I just plugged this point 1, 2 into this, into my z sub x and z sub y, and I got my values there. And then the tangent plane is z minus, the equation of a tangent plane is z minus z naught. You put your x here, your derivative in the x direction here, the derivative in the y direction here, and then x minus 1, y minus 2 is x minus 1, y minus 2. So I did the math and I got z equals negative 2x minus y plus 6. So that's my tangent plane for this point. And then whenever I go ahead and make it appear, there it is right there. All right, so we got a tangent plane to the surface itself. Now, what I can do also is I can, here's another upside down paraboloid. I can make the plane go with it, okay, which I think is kind of cool. So what I did here was I have my upside down paraboloid, and then I have a point c comma c. When you plug c and c in, you get 4 minus c squared. And then I figured out the tangent plane from that. The way I did that is, if you look, it's a little more complicated, but it's not hard, really. Well, maybe it's hard, but it's not impossible. I just plug in c and c. I let c be my x and my y. So what I'm doing is I'm going down the y equals x line. Y equals x line. If you look at the dot, take off the tangent plane. If you look at the dot, it's going down the y equals x line right there. All right. And then I plugged in what I needed to. I found my z sub x, z sub y, plugged in c and c, got those values there, derivative in the x and y directions, plugged it into my tangent plane equation, did some math, and I got z equals negative cx minus cy plus c squared plus 4. And that's what's down here. And so what I can do is now I've got a tangent plane that goes along with the point, the tangent plane itself. So I think it's kind of a cool little thing you can do on your own. So why don't you try that on your own and see what you get.